Hello, hello. I believe we are live and back with another episode of me reading scientific articles. And you can consider this one a Christmas special because we're talking about pine trees, conifers, otherwise known as. And I think they're really pretty trees. I like them. They're one of the only things that stay green over a harsh winter up north, and they're very nice. And apparently, they're growing and they're expanding, and they're pushing out the Arctic tundra in North America and kind of creating new forests. And so we're going to see what we can learn about that. So without further ado, we're going to just dive right into it. Okay. In contrast to expected range expansions, the primary response of North American spruce populations to recent warming in Arctic forest tundra at the Arctic forest tundra ecotone has been a growth form shift from stunted Krummholz to upright trees, an increase in stand density, or both. So spruce is a type of pine tree. Here's just so you can get kind of a image of it. I believe here's kind of a good image. I believe spruce are known for growing very tall and skinny. And a recent word I just learned, Krummholz, is when a tree is kind of bent over by the wind. And I love these kinds of trees. I think they look so cool. They remind me of like a horror story or like a horror movie. Just kind of have that gnarled vibe, you know. Anyways, however, even advancing boreal conifers cannot keep pace with ongoing isotherm movement. Holy crap. I just scrolled all the way down. Isotherm movement. The observed rates of tree line advance challenge simulation models to reformulate forecasts of boreal migration in response to climate change. The observed rates of tree line advance challenge simulation models to reformulate forecasts of boreal migration in response to climate change. Wow. To match post-last glacial maximum LGM migration rates of 3 to 4 kilometers per decade, modern range expansion by white spruce requires long-distance seed dispersal, or LDD. Successful germination by cold-sensitive seeds, rapid growth under limited conditions, and early sexual reproduction. So I wonder if all these things, the long distance seed dispersal, long distance seed dispersal, successful germination by cold sensitive seeds, rapid growth under limiting conditions, and early sexual reproduction. I wonder if those are all just like variables in people's computer models. It's wild that there's people who are trying to predict the future and turn these factors like I just mentioned into variables in an equation, which I feel like oftentimes proves to be correct, but that's modern science. White spruce dispersal distances are generally less than 100 meters, with successful germination requiring growing season temperatures of greater than 10 degrees Celsius. Okay. I'm sorry if you're European, but I need to know what this is in Fahrenheit. Nice. All you have to do is search it and it goes right to Fahrenheit. Okay, 50 degrees. Nice. So that's not that cold. Because seed production and quantity begins at 30 years of age, an estimate of range expansion is 0.03 kilometers per decade. Okay. 2 orders of magnitude slower than paleo rates. Detection of range expansion through remote sensing often relies on repeated growing season imagery of tree lines visible by virtue of tree height and density. Visible by virtue of tree height and density, established tree lines. However, young, sparsely distributed colonists extending a species range may go undetected without extensive field-based surveys. So I think this remote sensing that they're talking about and these established tree lines, I think they're just flying satellites or maybe planes over these forests to try to get a sense of how many of these white spruce there are. We describe a large, expanding population of young, vigorous, sexually reproducing spruce thriving within an Arctic watershed previously unoccupied by spruce for millennia, and advancing at rates approaching LGM last glacial maximum out of glacial refugia. And advancing rates approaching LGM migration out of glacial refugia. Using satellite imagery, figure 1, and field campaigns, we document the white spruce dispersal over Alaska Brooks Range, a 1,000 kilometer Arctic mountain range, long considered a barrier to forest advance. The oldest trees appear to have colonized during the late 19th and 20th centuries by dispersing over a mountainous divide form established tree lines in a basin supporting spruce over 6,000 years. I need to read that again. The oldest trees appear to have colonized during the late 19th and early 20th centuries by dispersing over a mountainous divide from established tree lines in a basin supporting spruce for 6,000 years. Wow. So, are they saying that in this area that they're studying, only spruces only arrived in the last 2 centuries, when on the other side of the mountain there have been spruce for over 6,000 years? Wow. Our observations suggest that winter winds, deep snow, and greater nutrient availability provide for rapid individual and exponential population growth, propelling the population northwards at over 4 kilometers per decade, faster than all modern conifer tree lines previously measured. These environmental factors are associated with rising temperatures and decreasing sea ice, highlighting interconnections between marine and terrestrial components in a rapidly changing Arctic. Identifying conditions for boreal forest advance will help parameterize and validate simulations aiming to forecast biome shifts. Okay, let's check out figure 1 here. So they're way up in northern Alaska. This is wild. That is very far north. And Alaska's huge. Colonist populations, established tree lines, AOI, I'm assuming, is area of interest. Northwest Alaska, USA. Separating boreal forest from Arctic tundra in Alaska's Brook Range as a olive green line. So I guess this is what it looks like from satellite imagery. Wow. Okay, so C is during a growing season. Okay. Forest, tundra, ecotone advance. And an ecotone is a term that means when one ecosystem starts to bleed into a different ecosystem. It's kind of the border between two different ecosystems. So this is the ecotone of tundra and forest. During a field survey in 2019, we discovered a previously unknown population of white spruce in the largest tributary watershed of the Noatak River Basin. The Noatak drains the western Brooks Range and at Kotzebue, and I'm going to butcher all these names, empties into the Chukchi Sea. And that's referencing figure 1A. Kotzebue, the Chukchi Sea, nice. Which is experiencing the fastest rate of sea ice decline in the Arctic Ocean. Wow. Across 10 to the third, which I believe is 1,000 kilometers of Arctic tundra within the area of interest. We geolocated 6,758 white spruces using very high resolution snow-covered panchromatic scenes, and 400 kilometers of field transects where we measured the ecological attributes of individual trees. Excuse me. Juvenile members of the colonist population were separated from established tree lines of the adjacent forest Kobuk River Basin by up to 42 kilometers. In the field, nearly all individuals appeared less than 100 years old and were growing rapidly. Trees of all sizes displayed erect, healthy, symmetric crowns and long leaders. We observed a near absence of tree islands. Chromolts, layering or other asexual growth typical at established tree lines. So these are all very healthy colonies. During a massed event in 2020, cone crops in some trees exceeded up to 1,000 cones, with 99% of cones bearing greater than 2.5 meters tall. Bearing colonists, sorry. The 8 oldest colonists were established in 1901 to 1933 near the Kobuk-Noatak Divide. 5.8 to 7 kilometers from an established tree line, suggesting several founding long-distance dispersal events. I wonder if you can see this mountain range in this map. Also, they reference figure 1D, but I don't see a 1D over there. Oh, that is in the extended data. Whoa. Went way too far. All right, here it is. Okay. So this is just the area. This is a close-up of the area of interest. So I feel like shadow density, that's like a good indicator of how dense the populations are. The Noatak Kobuk Divide, this is the mountain range that has kept spruces on the other side for 6,000 years, so they claim. But they've found a couple of trees that seem to have sprouted on the other side of this mountain range in 1901 or 1903. Oh, from 1901 to 1933, sorry. Okay, let's get back to it. All right, this is where we at. Patterns of expansion. Trees greater than 2.5 meters tall grew considerably higher in elevation and or further north than the nearest established tree lines. Individuals less than 2.5 meters tall, juveniles, were often higher in elevation and or further north than the adults, whereas adults had reached a maximum distance from the established tree lines by the mid-20th century. Juveniles have continued to move northwards and upwards during the 21st century. For 5,988 mapped adults, the maximum northward displacement from the nearest established tree line was 0.16 degrees. North, 95% quantile, 9.7 kilometers north. Okay, yeah, I don't think I should read that. That's, I think this is latitude and longitude. But figure 2A, okay, elevation relative to tree line. Adults, distance north of tree line. Okay. Huh. The migration rate of the furthest forward adult still substantially lags the accelerating rate of isotherm advance, but far surpasses the migration rate estimated for tree lines lower in the lower Noatak Basin, 175 kilometers west. A full depiction of range expansion includes a dispersal kernel portrayed here as a bivariate distribution of juvenile distance from a juvenile distance from an elevation relative to the nearest adult. Okay, bivariate distribution. What does this mean? What is a bivariate distribution? A statistical method used to show probability of two random variables occurring. Okay. That's figure 2B. Juvenile's distance north of adult. And that is in kilometers. Elevation relative to the adult. So it looks like they're mostly they're mostly staying close to the mother tree. Except I get some are branching out over here. This is kind of, I've never seen graphs like this before. This is kind of hard to interpret, at least for me. Mapped juveniles were mostly near adults. However, at 5 locations, over 1.2 kilometers from each other, 14 juveniles were 9.3 to 22.9 kilometers north of the nearest adult, and 26.6 to 40.2 kilometers north of the nearest established tree lines. These distant juveniles were each less than 35 years old, growing vigorously. Without evidence of Krumholtz layering or other asexual reproduction. Some appeared mechanically broken through antler racking by migrating caribou, but most had upright leaders. We documented with global navigation satellite systems hundreds of juveniles up to 392 meters above and 215 meters below the elevation of nearest adult. Of the nearest adult. Juveniles growing more than 100 meters above the nearest adults grew as populations on ridgelines in low or dwarf shrub communities. That makes sense. Juveniles growing substantially below the nearest adults grew on river bars with tall willows in tussock tundra. So, interesting. So, I think what it's getting at here is it's just pointing out that the trees are able to survive at a wide variety of altitudes, but they are growing smaller when they're at the high altitudes. Conventional white spruce silvix, white spruce silvix identify, what the heck is that? What is silvix? The study of life history and characteristics of forest trees, especially as they occur in strands, with particular reference to environment. Oh man, that's such a cool word I did not know. Silvix. Wow. Conventional white spruce silvix identify 45 to 60 meters as the typical dispersal distance, closely bounding the median distance between juveniles and their nearest adults, and over 300 meters of long distance seed dispersal. Here, 32% of juveniles were over 300 meters from the nearest adult, and 13% were over 800 meters distant. Snowdrifts visible on imagery and wind direction obtained from nearby weather stations show strong, frequent southerly winter winds, supporting hypotheses of frequent winter wind-driven dispersal from both empirical studies of modern dispersal and a conceptual model of range expansion in white spruce following LGM, the last glacial maximum. Okay. Population and individual growth. A hallmark of plant invasion ecology is the recursive founding of small populations following long-range seed dispersal. Long distance seed dispersal, LDD. Applying this theory of the invasion to white spruce in the upper Noatak Basin implies that exponential population growth drives local range expansion forwards. To test this hypothesis, we constructed past populations in a well-sampled sub-watershed with 1,000 resamples from establishment year probability distributions conditional on 5 height classes. Fitting each simulation with as a population size n equals n naught e to the k times t minus 1900, where t is the year and k is the exponential growth rate, gave a mean k of 0.07 per year. On average, the simulated populations doubled each decade. From 1900 to 1980. As a result, that was robust to reducing the number of height classes to 3. An example simulation shows the spatial clustering and rapid population growth in the 1970s. Man, I don't know how to get access to these supplementary videos. It's difficult for me to find a free PDF of this. But as I get more professional, I will have videos that to go along with these things. Individual growth is an implicit constraint of vital rates in populations. We measured individual growth with 3 metrics relative to Kotzebue July air temperature. The growth metrics included current annual lateral branch growth, CAG, in adults during the warmest July 2019 of the continuous Kotzebue instrumental record. Wow, so 2019 was the warmest month that they have measured in Kotzebue, and they've been measuring since 1937. Relative height growth rate, RGR, in juveniles over the warmest 5 consecutive Julys, and main stem radial growth over warmest 3 consecutive decades as compared with prior growth. Radial growth measures included raw ring width, basal area increment, and autoregressive residuals. So raw ring width, I'm pretty sure that's just counting the tree rings to determine the age. No, none of the here, let's see here. Radial growth measures. Yeah. Basal area increment. Let's see what this, if we can get any information on this. Basal area increment and basal area growth efficiency based on fitted equations indicate that increments in the product of leaf area and height to the center of leaf area must increase yearly for either basal area or increment or growth efficiency. Wow, so the U.S. Forest Service has a whole page on this. This is a whole nother. Okay, this is not what we're looking for. Let's see if we can figure out what autoregressive residuals are. Trees. Okay. These are ways of measuring growth. I believe, yeah. Radial growth, that is not like how tall it is. That is like the width of the tree. The AR index reflects interannual variation with temporal autocorrelation removed, whereas the raw ring width and the basal area increment reflect growth trends. Kotzebue July air temperature is probably very well correlated with July air temperature in the area of interest, given the strong, consistent July lapse rates in the Baird Mountains. All three growth metrics showed that the colonists grew more rapidly than individuals at established tree lines. That's kind of interesting. I wonder if that is because they have more space or something. Adult colonists, CAG, what was that again? Sorry, I have to figure out what CAG means again. I see it right here. Current annual growth. Almost double that at tree lines. Wow. So they've crossed these mountains and they seem to be in like a vast expanse where they just have tons of room to grow and the right conditions. Juvenile colonists, RGR, oh my gosh, there's so many acronyms. Relative growth rate, juvenile colonists' relative growth rate was greater than at established tree lines with a difference that increased with height. Such relative growth rate was 1.9 times that established tree lines in the height class of 80 to 160 centimeters. So almost double that at the established tree lines. Both radial indices of colonists increased exponentially from 1989 to 2019. The exponential growth rates of adults and juveniles during the most recent decades contrast with earlier rates reaching back to the 1950s, including comparisons of growth rates of all trees as juveniles. Wow. Correlations of both autoregressive residuals and basal area increments and in basal area increments with 1989 to 2019 July temperature were positive for all trees less than 30 years old and 90% and for 98% of older trees. To our knowledge, this is the highest proportion of adults responding positively to temperature recorded among tree-lined sites in the Brooks Range. However, the spatially comprehensive chronologies for the Brooks Range presented in reference end in references end with, sorry, the period threw me off there, end with the 20th century, leaving uncertain how widespread the recent rapid radial growth might be. A localized Brook Range tree ring chronology ending in 2011 showed a strong response to recent warming with sampling well below the tree line in the lower Noatak Basin on a riverside terrace with relatively high soil nutrient availability in warm soils. This chronology contrasts with chronologies from nearby sites with cooler, more nutrient soils that fail to show a similar response in warming. Okay. Moving on to the environmental conditions. Rapid Arctic warming affects colonists through multiple pathways, including increased snowfall and improved nutrient availability, which probably interact to improve juvenile survival and adult growth. To explain the longitudinal gradient and radial growth response temperature across Alaska's Arctic tree lines, advanced the hypothesis of nutrient limitation induced by cold soils, whereby soil nutrient availability axis are both constrain growth and reproduction in individual trees. Okay. So to explain the longitudinal gradient and radial growth response to temperatures across Arctic tree lines, this group of study, Sullivan et al., advanced the hypothesis of nutrient limitation induced by cold soils. So they're saying at a certain point, at a certain distance north, the trees will grow. They won't grow further north. They'll grow to the sides because the soil is too cold north. In line with this hypothesis, we found higher foliar N and P concentrations and higher ratio of N to N, an index of mycorrhizal associations. Wow. Don't really know how to say this, guys. This is don't really know what that symbol is. I know it's like I'm just gonna call it sigma. I don't know if I don't think it's a sigma, but we're just gonna go with that. Where sigma to the 15n equals 1,000 in colonists. In colonists, then in the established tree line populations, although colonist sample size was much lower, greater access to nutrients increases growth and may reduce mycorrhizal carbon costs. Yeah, that's rough. Regional winter precipitations is increasing as a consequence of rapid regional warming and sea ice loss. From 1979 to 2019, both the extent of open water in October in the Chukchi Sea and winter precipitation in the Kotzebue increased. Modeled and empirical data suggest that increased open water in the Arctic Ocean during autumn leads to more wind and deeper snow. Increased wind over sufficient protective snowpack facilitates the physical transport of seeds in long-distance dispersal. These conditions encourage colonization of tundra by boreal conifers well beyond current population boundaries as predicted by invasion models. So they're having more storms. The sea ice is melting, so it's reflecting less light in the area, so more heat is being absorbed in that region of the world. So that combination, the storms are blowing seeds further. Oh, and this saying, so the increased open water in the Arctic Ocean leads to more wind and deeper snow. And so the increased wind over a sufficiently protective snowpack facilitates the physical transport of seeds. The increased wind over a sufficiently protective snowpack. So is the snowpack, what's confusing me here is why is the snow, how does the snow facilitate the dispersal of seeds? Maybe they'll get into that. Arctic winter precipitation offers a proxy for snow depth, a factor providing thermal insulation and promoting overwinter activity by soil microbes, thereby increasing soil nutrient availability during the subsequent growing season, an effect first proposed for Arctic shrubs. Okay, this makes sense now. So what they're saying is when you have a deep layer of snow, it protects the soil, the surface of the ground, from being exposed to wind, being exposed to rain, being exposed to animals, and it allows, despite what you might think, since it's very cold, it allows microorganisms to thrive underneath all the snow. And this is one of the reasons why the Midwest and other areas in the Eastern Hemisphere that experience snow have some really great, really nutrient-rich soils. And it's also why a lot of people are now suggesting to farmers to plant cover crops so that they don't leave their bare ground of their farms exposed when it's not during the growing season. Okay. Increases in winter and growing season soil temperatures are expected to increase nutrient availability, a known limiting factor for spruce seedlings in tundra. Snow protects juveniles, and snowmelt reduces moisture limitations during the growing season. Okay, yeah, so then when the snow melts, these new seedlings already have an abundance of fresh water. Snowpack affects population level responses to damaging winter winds because growth form determines seed production. Taken together, these factors highlight the complex and nuanced interactions among nutrients, climate, vegetated growth, and reproduction. Yeah, this is really cool. To investigate differences in colonists and established tree-lined climates, we compared simple bivariate climate envelopes using gridded climate data for 30-year means of July temperature and November-March precipitation. We chose July temperature because it was strongly correlated with growing season degree day sum, the top univariate predictor of white spruce presence in the tree line of the Brooks Range. So July temperature is the thing that's most highly correlated with these populations. Both populations occupied areas with July mean air temperatures greater than 10 degrees Celsius 50 degrees Fahrenheit. But climate envelopes were cooler and snowier for colonists than for individuals at established tree lines. This mode for established tree lines was near the Kobuk sheds, where colonists occupied the snowier end of climate space in Noatak watersheds. The misalignment between climate envelopes and the establishment of tree lines and colonists implies caution when predicting range expansions on the basis of gridded climate data. The results here that established tree lines may not provide appropriate examples of patterns and processes involved in forest advance. Corroborating studies in central Alaska, where experimentally elevated temperatures increased growth more at locations above the tree line. The metrics indicated more rapid growth in colonists than in individuals from established tree lines, also parallel measurements showing greater productivity at forest margins than within forests in Alaska. Okay, so that whole section was talking about these graphs here. So this is established tree lines, and this is July temperature, and this is winter precipitation. Okay, so yeah, so I'm assuming that the yellow means that there's more dense populations. Yeah, so the colonists are further north, so there's a lower population. Interesting. Okay. Regional extent. The area of interest population is not the only one to recently colonize a tundra basin in Arctic Alaska. Within Northwest Alaska watersheds distant from the area of interest, we discovered 4 other spruce populations that during the last 3 decades have dispersed across mountains, forming the boreal Arctic divide. So this is not just happening in this area. Advancing at a median speed of 4.9 kilometers per decade from established tree lines, 4.8 to 25.5 kilometers away, these nascent populations of a few small, young individuals may represent the first post-last glacial maximum colonists to arrive in their respective Arctic watersheds. Spanning 20 degrees of longitude, 143 to 163 degrees west, and equivalent to 20% of the white spruce's entire east-west range, small populations of 1 to more than 70 individuals grow vigorously well beyond established tree lines. The fewest colonies occurred in the eastern Brooks Range, where winter precipitation is lowest. Colonists most distant from established tree lines occurred in the west, where winter precipitation is highest. That makes sense because it's close to the ocean. A larger number of colonized watersheds were found in the central range. In one instance, 150 kilometers east of the area of interest and 25 kilometers from the triple divide of the Noatak, Kobuk, and Koyukuk basins, we resurveyed a 4 kilometer square a 4 square kilometer valley previously censused above and beyond the established tree lines. There, spruce had increased in number by a factor of 12 over 43 years. Wow, that's crazy. Wow. It's more than an order of magnitude. Doubling every 1.2 decades and increasing in height from a population of juveniles less than 1.2 meters tall to one including adults 8 meters tall and bearing cones. At the northeastern range limit of white spruce in maritime Labrador near Hudson Bay in Canada, field studies have also reported forest advance during the 20th century. By contrast, remote sensing studies in the continental area between Hudson Bay and the Mackenzie River Delta have found leading-edge disequilibrium and even forest retreat. During the last half of the 20th century, the most rapid modern expansion of boreal tree into Arctic tundra so far reported is for mountain birch, a small deciduous broadleaf tree advancing across Fennoscandia in northwest Eurasia at rates similar to those seen at the white spruce here. I wonder if Fennoscandia is like near Finland and Scandinavia? Yeah. Okay. It's just another word for Scandinavia, I suppose. Arctic-wide greening trends from high-resolution satellite imagery during 1985 to 2019 also suggest a global boreal biome shift northwards as temperatures continue to rise. Over time, warming, both directly and indirectly, will support higher latitudes tree establishment, growth, reproduction, and dispersal, particularly with increased southerly winds, greater snowfall, and increases in nutrient availability, all induced by warming. Okay, we're about to get to the conclusion. And we're almost to an hour in here. The proliferation of spruce trees in the 20th and 21st centuries we described represent a climate-driven invasion of Arctic tundra occurring at greater than 4 kilometers per decade, matching the post-glacial maximum rate of white spruce migration out of glacial refugia. Previous population reconstructions of spruce at the range limit found rapid infilling during the latter half of the 20th century. But the incremental expansions documented in most studies are an order of magnitude lower than here. The orders of magnitude difference between forest migration and the rates of isotherm movement leave vegetation increasingly out of equilibrium with climate. How modern forests will respond in the face of changing climate remains poorly understood, and studies identifying instances of rapid advance may suggest mechanisms that LDD, long-distance seed dispersal, facilitate sapling recruitment and increase sexual reproduction. Decades behind the range expansion of tall shrubs, conifers may be on the verge of a stochastic, climate-driven invasion of tundra after centuries of stasis. Seedlings have established populations undetected by remote sensing in the relative inaccessible Arctic, where beds of knee-high spruce will become trees of 4 to 5 meters in height with heavy cone crops in 50 years. This increasing Arctic tree cover is accelerating as a consequence of and feedback to climate change that will shift subsistence resources available to Arctic peoples, decrease habitat for migratory species, and reduce land surface albedo and redistribute carbon stocks, all with global implications. So there it is. That is the study. So I wish they had some cooler pictures of some trees here. But here, you know what I'll do? I'm going to pull up real fast a map of Alaska. And oh man, how do I do this? I guess I'm just going to search it in here. I'm trying to be clever about how I No, we want satellite. All right. So let's see if we can find. Yeah, here's Kotzebue. Sorry. So here's Kotzebue, and here's Noatak, and here's this mountain range here. And this mountain range has effectively kept conifer trees. The one they're specifically studying in this study are the spruce trees, are the white spruce. They're specifically studying white spruce trees in this study. But this mountain range has effectively kept them on the southward side for more than 6,000 years, and we're only just starting to see over the past few centuries some of these white spruces make it to this northern area, and they're reaching a point where they're doubling every decade, and they're starting to reach an exponential growth. And one of the reasons for that is we have the melting of these Arctic ice up here is creating a lot more storms, and these trees spread their seeds through wind blowing their seeds. And so these these increased storms are blowing these seeds over these mountain ranges, and then the seeds are being covered in snow, and the snow are letting them incubate. They're building these fungal networks over the winter, and then when the snow melts, they're getting all this fresh water right when they need it most. And so these scientists are basically predicting that we're going to see a rapid growth of forest in this big chunk of northern Alaska here. And it's going to completely change the ecosystem. It's going to create these feedback loops, because one thing that kind of keeps northern areas cold is snow. When you have snow year round, it reflects more light, and it keeps heat from absorbing in there. So yeah, this study was super interesting. Did a little bit, definitely some stuff I did not know how to explain, and stuff I did not know in general, and stuff I didn't feel comfortable doing like a deep dive into figuring out on a stream. But yes, super interesting study, and thank you guys for watching this.